Hi guys, let's hit 1.4. We're only going to do a very basic covering of it because we are also going to be doing 1.5 or beginning 1.5 in this video. Um, the homework for 1.4 is 29 through 43 odd. You don't have to do them all. Just make sure you get it because you're going to need it when you get to the following sections. Okay, I is what represents the imaginary number. Well, what does that mean? Real numbers we're used to, right? It's just the things on the number line. But sometimes you have to take a square root of a negative, and it seems like an imaginary number would be not useful or whatever. But if you flip a light switch and the lights come on, or you use a cell phone, or you do anything that involves any kind of technology, um, all of that science is based on understanding the imaginary number and being able to use it. I can't explain that, I just know it's true because once you get into trig, all of the trig functions are defined as functions of with i's in them. So I represents the square root of a negative. So anytime you have a negative number under a radical, a square root, you're going to get an I in your answer. And oh, by the way, anytime you take a square root of something, you need to say plus or minus. We'll talk about that more later over and over and over again. So you have this equation where I represents the square root of a negative. If I square both sides of this equation right here, when you square a square root, you get the thing underneath. So I squared equals -1. You will never, ever, ever have an I squared in your answer. You always change I squared to a minus sign. Okay? Now, take this take this equation right here and multiply both sides by I again. So -1 times I is -I, and this is I cubed. So you will never write I cube in your answer. You will take two of these guys and make them a negative, and then you have the third one there. Okay, take this equation again and square both sides. If you square a -1, you get a +1. When you square something that's already squared, you multiply the powers and you get I to the fourth. You will never, ever, ever write I to the fourth in your problem or in your answer. You will change that to a +1. Now, this is really cool because now you can see that, let's say, I to any power, pick I to the 23. That's I to the fourth. How many times? 20, right? That's I to the 20th times, we've got 3 left, right? So there's 2 there and 1 there. Do you see it? When you multiply these powers, there's I to the 20, I to the 22, I to the 23. Now, write those guys as your answers. I to the fourth is just 1. Raise that to the 5th power. 1 to the 5th is 1. I to the 2 is -1. And I is just I. And you see that I to the 25th just equals -I. You will never have I to the power in any answer. It's either +I, -I, or plus or minus 1. Okay, when will you use this? Never for me. You're going to be using I by taking the square root of something that's negative and writing your answer with an I in it. But we do need to know how to use I's, so let's continue. Okay, I is the imaginary number, but we need to talk about complex numbers. Complex numbers are of this form. This is what's called standard form, and for a couple of decades, students were required to always write their answer in this exact form, where you had a completely real number and plus or minus here, but b, if b was a negative number, that would be a minus, right? B is a completely real number, and then you had the imaginary stuck out on the end. All numbers are complex. 3 is a real number, right? But that's just 3 plus no i's. 4i is completely imaginary, right? But that just means that the real part was 0 and you have 4 i's. Okay? So all numbers are complex, and I'm not going to require you to write all of your answers in perfect standard form. I don't think your textbook actually does either, and that's okay. We'll talk about that on the next page. You need to be able to take something that looks like this and write it where you never, ever, ever have a minus under a radical, and you always reduce all of your square roots to their simplest form. Do not write the square root of 4 in your answer, because the square root of 4 is 2. You always and forever simplify radicals. You don't even have to ask me, you know you have to. And you, just like you always have to reduce fractions to lowest terms, no matter what. You don't have to ask me. You should just know that you have to do that. Okay, so let's pull this thing apart. This guy underneath here is 4 times negative 1, correct? And if they're both under the radical being multiplied, then you can multiply each square root. The square root of 4 gives me a 2, square root of minus 1 gives me an I, and you're done with that problem. Now let's look at this. The square root of minus 8. There's a negative 1 here, but 8 is 4 times 2. You will never write the square root of 8 in your answer, because you can take the square root of the 4 and then the square root of 2 and the square root of the minus 1. Square root of 4 gives me 2. Square root of 2 you can't reduce. Square root of minus is an I. This is in standard form. There's a 0 plus in front of it that you don't have to write. Some of you in high school, and I did too, were taught to put the I in front of the radical. And the only reason that we learned to do that is so that you were never confused about whether the I was under the radical or not. That's the only reason to put it between the whole number and the radical. This is standard form here. This is also acceptable. Okay, this is what your homework looks like for this section. What do you do if you're combining things that have negatives under the radical? Well, you have to reduce each of these guys, okay? So let's talk about this. 8, we've already done 8. That was a 4 times a 2, and the minus becomes an I. 18 is 9 times 2. 9 is a perfect square as well. So what you're going to do when you do these problems, you know you have an I. You're going to take the square root of 4 and get the 2. Square root of 2 is just square root of 2. Then when you have this guy, you've got an I with the minus sign. And then take the square root of 9, which gives you 3. Square root of 2 can't be reduced. Now look at what you have here. Remember, you can only combine like terms. And we do that with x squareds and x's and constants. But we also have to do that with radicals and i's. And you see that this guy right here, I'm going to put a little highlighter there. This guy right here is the same as this guy right here. So all you're doing, that makes them like terms. All you're doing is adding 2 of these things plus 3 of these things, and you get 5 of these things. Make sense? Let's see the next thing that we have to do. What if you're subtracting or adding complex numbers? Well, in this case, you have to distribute that minus sign. If it was a plus, you could just write down the answer. But because it's subtraction, both of these bits are getting subtracted. You're subtracting the 4 and you're subtracting the negative 3i. Now, the 3 and the 4 are like terms. So we're going to, hold the phone, we're going to add the 3 and the negative 4, and then we're going to add the 2i to the 3i. That's combining like terms. So now we end up with the 3 minus the 4 is -1. 2i's plus 3i's gives me 5i's. And there's your final answer. Now, what if you're multiplying? You see when parentheses touch each other, that indicates multiplication. But these complex numbers, you actually have to go back to your FOIL method because those are not like terms inside the parentheses. So we're going to do the first times the first. 3 times 4 gives me 12. The outers is going to give me a positive times a negative is a negative. 3 times 3 is 9, and you have the I. See that? Just like multiplying out x's. The inners here are going to be positive 8i. Boom. Now the last times the last, we've got a positive times a negative, which gives me a negative. We have a 2 times a 3, which gives me a 6. And we have I times I, which is negative, which is I squared. Wait a second. Didn't I say before that you are not allowed to have a I to the power? Right? So what are you going to change that to? Well, you're going to change that I squared to a -1. Also, minus 9i plus 8i gives you minus 1i here. So we have the 12 from the front. These combine, just like if you were multiplying out two binomials with x's, you're going to get -1i. This guy right here is a minus 6 times a minus 1. Well, that just gives me plus 6. And then once that's done, you see that you have like terms that you need to combine. 12 plus 16 gives me 18 in the front, and you're subtracting an I. So practice that a little bit. It's not part of the homework. The homework is this stuff right here and the stuff that we're going to be doing when we use the quadratic formula, which is coming up soon. Okay, let's do multiplication again. So I have 2 plus 3i times 2 minus 3i. That should trigger something. Remember, a squared minus b squared is a plus b times a minus b. Those guys are called conjugates, right? Well, these, because they have i's in them, are called complex conjugates. And you'll see that when you multiply complex conjugates, something very special happens. So again, we're going to FOIL. 2 times 2 is 4. Then we're going to get minus 6i for the outers. And then the inners is going to be plus 6i. And these guys are going to cancel out. So we have the 4 from the front. This is a 0. And then the last times the last, look at this real quickly. We have this guy right here multiplying this guy right here. So you see, in this case, and anytime you do complex conjugates, there's going to be one plus and one minus, which is going to give us subtraction. The numbers are the same, so that's 3 squared, which is 9. And then we have an I times an I, which is I squared. And we already said, what does I squared become? It becomes a -1. So when we have this -1 right here, which we will always get when we're multiplying complex conjugates, we will always have a minus. It'll always be subtraction because it's a squared minus b squared. So this is always subtraction, but you always have that I squared. So when you're multiplying complex conjugates, you will always get a plus in the middle. If you remember this, your life's going to get a lot easier. The inside terms cancel, just like a squared minus b squared. But when we have the minus b squared, it's going to be minus a negative every time, which gives us plus b squared. These are both real numbers, so you add them together. Do you see what happens? When you multiply complex conjugates, you get a real number, and that is a huge thing. And here is your rule here. When you've got a plus bi, a minus bi, it's just like a plus b, a minus b. But because of that I, you end up with addition in the middle. And if you don't know what I'm referring to when I say a plus b times a minus b, that's a special product that you better review, because you have to be able to look at these guys and factor them immediately. A plus b, a minus b. So if you have x squared minus 25, you have to know that that's x plus 5x minus 5. Please remember this, okay? So in this box right here, these are real conjugates that multiply out to be a squared minus b squared, all right? So if you FOIL this out, there's no I there, you'll see you get a plus times a minus. It's that. What's most important here is that you have to be able to see something like this and recognize their squares. If it's subtraction, boom, you're done. You know how to factor that, okay? If it's plus, then you had complex conjugates. Remember, you were taught that factoring a squared minus b squared is a plus b, a minus b. But factoring a squared plus b squared, you were taught that you can't factor that. The reason you were taught that is because of those i's right there, okay? They do factor, but they factor as complex numbers. Okay, what do we use complex conjugates for? Well, lots of stuff. But one of the things that we use them for is division of complex numbers. There is no such thing. You don't divide complex numbers. You rationalize the denominator. What does rationalize mean? Well, some dead Greek guy said that you can't have a square root in your denominator because he didn't have a calculator like you do, okay? So to rationalize a denominator means to get rid of the root in the bottom. And you always, if it's addition or subtraction, you always multiply that by the conjugate, okay? In this case, it's a complex conjugate. So if I started with 3 minus I have to multiply by 3 plus I. If I do the bottom, I have to do the top. Now watch what happens. It's the bottom that I'm messing around with, so I'm not going to multiply out the top. I'm going to leave it factored until I see what's happening. Okay? The last thing I'm going to do is distribute on the top. All right? On the bottom, I have complex conjugates, and double check yourself. You get a 9 here. You're going to get plus 3i on the outers, minus 3i on the inners. They go away. So the last times the last is minus I times plus I. Minus I times plus I is going to give me minus I squared, which equals positive 1. Because I squared is a negative, and you're subtracting it. All right? So we end up with the 3 times the 3 plus 1 times 1, or minus 1i squared. Now this combines to be a 10, and it's a good thing I didn't multiply out the top yet, because you can see I can reduce my fractions, and you don't have to ask, you always do it. I'm left with 3 plus I on the top and 5 on the bottom, and this is good enough for me in this class. But if you want to put it in standard form, you're going to take each of the pieces in the top and divide them by that number in the bottom. You see I've got 3/5 plus 1/5 I. This is standard form. This is acceptable and actually easier to see. All right, here's the reason that we had to learn that stuff in 1.4. Because in 1.5 we start doing something called extracting the root. What this is used for is anytime you have a perfect square and a number, you can isolate that square, take the square root of both sides, and get your answer, okay? But you have to remember, anytime you take the square root, anytime you take the square root, and that's important, don't forget to write plus or minus. Okay? If there was a square root in the problem to begin with, it was either positive or negative. But if you take the square root, you have to say plus or minus. Okay? Because if this was a negative square root of 5 and you squared it, you were still going to get that positive. If it was a positive square root of 5 and you squared it, you got a positive. So anytime you take the square root, you have to allow for the possibility that it could have been a plus or it could have been a minus. And another thing, you see that this x is squared? This equation should have two answers. And it does. It has the plus answer and the minus answer. Now notice how I started with x minus 5 and I've moved the 5 over to the right. You're going to isolate the thing that's a perfect square, take the square root of both sides, don't forget plus or minus, and that's this whole bit in a nutshell. What if I had x squared plus 5? I move the 5 over and I've got x squared equals a negative number. Now up until today, you were told there was no solution, but you actually had no real solution. You had a complex solution. Actually, you have two complex solutions. So you take the square root of both sides. Square root of a negative gives me an I. Square root of 5 is just the square root of 5, and don't forget your plus or minus. So practice this stuff, and now let's build a little bit on this. So what if I have blob to the power? You're going to hear me talk about blob a lot because blob is very important. And I'm lazy, so I don't like to say quantity x plus 1 squared or x plus 1 quantity squared. I just say blob. Okay, you see what I'm talking about. If I have blob squared equals a number, I've isolated the thing that was squared. Notice that the square, the exponent, is touching the parentheses. That means the entire thing is touching. Now, up until now, you would have written x plus 1 blob times x plus 1 blob, FOILed it out, moved the 3 over so it equals 0, refactored it, or tried to solve for x. But if you did that, you would get something that was not factorable. And I can tell that by my answer. Okay? If a perfect square blob equals a perfect square, then you could have factored it. But this isn't a perfect square. So watch what happens. You isolate the perfect square side. You take the square root of both sides. You don't forget the plus or minus. Square root of 3 is just square root of 3, but that leaves me with x plus 1 on the left. I don't care what x plus 1 is. I want to know what x is. So I'm going to subtract the 1 from both sides and get my final answer here. Doesn't that look like you used the quadratic formula? Oh, yeah, it does. And you'll see why pretty soon. Okay, perfect square blob plus 4 equals 0. I'm going to move that 4 over to the other side so it's negative. That isolates the perfect square. I take the square root of a perfect square, I get the stuff underneath. Take the square root right here. Let me write that in there real quick. The square root of this, the square root of this. Don't forget the plus or minus. The square root of 4 is 2. The square root of the minus gives me the I. I still have x minus 2 on the left, so I add 2 to both sides, and I get my final answer right here. You always simplify your roots. You always reduce your fractions to lowest terms, and you don't forget the plus or minus. One more. Blob squared equals negative 8. Take the square root of blob squared, you get the stuff inside the blob. Take the square root of this dude, I have to write plus or minus. This 8 is 4 times, let me write this down, hold it. 8 is 4 times 2. So the square root of the 4 gives me the I. I'm sorry, the square root of the minus gives me the I. Square root of 4 gives me a 2. Square root of 2 is just square root of 2. So this is what I have now. I have to isolate the x. So I'm going to subtract 1 from both sides. That gives me this guy right here. And then I'm going to divide away the 2, which just makes it a fraction. This is perfectly acceptable. It's probably the way your book wants it. You can even stick that I right there in between the number and the radical if it makes you comfortable. Or you can put it in standard form, which means the negative 1 is divided by the 2 right here, and this 2 square roots of 2 gets divided by 2, which leaves me with just plain old root 2 and the I. Okay, guys, go for it. Let's look at the last page. For this video, you've got homework assignments in 2 different sections, and this is just the little bit of stuff at the beginning of section 1.5. That looked like an exclamation point when it was supposed to be a colon. Okay, so you're going to do this, just enough of them that you understand how to reduce those radicals and make them simple and how to pull out the i's. And then I want you to hit this homework. Get used to doing these things because the next two topics, completing the square and the quadratic formula, are going to end up with you having to do this and then simplify your answer. Okay, go for it. Get it done quickly because got lots more videos coming.